Recording, here we go. Hey, good morning, everybody. Welcome to week 3. All 5 of you. I'm doing a screenshot for that one. Alright, fame and glory points for Fab 5. How's everybody doing today?
I'm very tired.
I'm with you. Yeah, I've never napped as much as I have, like, in the past couple of quarters at Clark. Alright, let's see. So, I want to talk a little about PA1. I want to mainly talk about PA2, and then start digging into some of the material related to PA2, some of the new aspects with hash maps and scanning from files and so on. But let me start with PA1. PA1 was fabulous. Really, really great work from everybody. And in past quarters, I've just done PA1. It was just, writing a class in Java, usually for fractions or rational numbers or something, and people struggle with it. And right now, everybody in this class, I think, is far beyond where people have been in previous offerings of this course. Because it looks like people understand classes, at least from kind of a higher level perspective, and you were able to create a class, right, for a stack and for a queue, and then use it as a class, as a Java style thing, and that's fantastic. So lots of hundreds on the programming assignment, which is always great. I gave feedback even if you got a perfect score. I put some feedback in there, just for a few things. One of them being related to toString, and every object has a toString method, right? Yeah, if you got no feedback, it's a good thing. Unless you lost points and then I messed up. If you lost points, there should be feedback. But if you got 100 and you didn't get any feedback, I had nothing to add to it, so everything looked perfect. toString, right? Every object has a toString method, and the general purpose of toString is to return a string representation of your object. Linked lists have a toString method, which give you, a comma-separated list of things inside square brackets. And so a few people still, to create their toString method, iterated through each object in their linked list and concatenated them together into a string using commas. You do not need to do that, right? You can use, if you created a linked list stack, right, you could simply take TOS arrow plus stack, and when you do this concatenation, the toString method of stack is called. Well, stack is a linked list, so it will call the toString method defined in the linked list class, which will return a string that looks like this. And so this expression will be the same as the string TOS arrow square bracket comma separated list square bracket. So you could do plus stack dot toString, but that'll do exactly the same as just concatenating stack. And you could go ahead.
Can you kind of explain to me about exactly what a toString method does? Is it basically I was assuming that a toString method is basically getting all the entire content of what's stored inside of a variable. But I don't know if I got that definition right.
Well, for a linked list, that's perfect. For a linked list, it takes the content of each node and strings them together in a big long string with commas in between them and square brackets on the sides. But that's just for a linked list. For our rectangle class, the toString method made a string that said, a something by something rectangle. Because that's what that toString method did. It's different for each class. But usually it's doing something to give you some kind of human readable representation of what's in the object. Yeah, this is PA1B. But the specifics depend on how the class is written. So for a linked list, it gives you this, and for the myStack class that you were writing, it was supposed to give either this or something like that. Now, if you wanted your toString method in myStack to just return this, right, you could simply return, well, you could return stack.toString, which will give you back a string. But if you try to return stack, you'll get a compile error. Because your toString is expected to return a string, and stack is a linked list. Well, it's a myStack, actually. But, and so you could call toString, but you can also do this. You can concatenate to an empty string, and that's enough to compel the system to say, okay, let's find the toString method in stack. Let's call that. Let's take the string that we get back. Let's add nothing to it, and then let's return that. So this will do exactly the same thing as that. And this is, two double quotes with nothing in between. There's not even a space in there. If there's a space, there'd be a space at the end. You could also do quote, quote, plus stack. And that'll do exactly the same thing. And appending an empty string to the beginning or the end doesn't change the appearance. So all three of these would do exactly the same thing. So that's just a kind of nuance.
Which method do you prefer the best?
If you can get away, well, I don't think it makes any difference to me. I usually do this just because I don't like camel casing, I guess. But they're all the same. So whichever you like.
Okay.
Try catch. So my only comment on try catch is well, I got a few comments on try catch. So we were using try catch to parse the input and see if it was an integer. So try num equals integer dot parseInt some input, catch something. All right. So so first, most people did a great job of only doing this inside the try block and doing everything else outside the try catch block, right? Little bit of wiggle room. Some people went ahead and did the stack push or the Q add inside the try block. Not too horrible a thing to do, but be careful of the slippery slopes, right? So usually we want to put the try statement around the thing that could fail, and that's it, right? And so if we find an error, we want to do something like a continue, or we want to set a flag or something. And then outside of the try block, we would say, go ahead and push the number to our stack. Or if we're in queue mode, add the number to our queue, or whatever. But, keep this pretty tight. There were a few cases where there was a lot of code inside the try statement, and that starts to get to be worrisome. So you want to keep these as succinct as possible. The other thing is that, if this statement succeeds, the whole statement is executed. So after this, num will be the integer value of whatever this string was. And there were a few cases where outside the try catch block, this statement was repeated, right? You don't need to do that. If this statement executes, num will be the value that you want. You don't need to again say num equals integer.parseInt. So you're not just checking to see if this statement can be executed, you're actually executing it. That's the detail. Let's see, anything else? I think that was about it. Again, make sure you look at the feedback, because there's some things I mentioned in there that I did not take off points for on this, but I would definitely take off points in the future. So if you got 100, don't just, ignore the other comments.
Well, if I take down some feedback, it makes me kind of concerned about what are you taking points off for future references.
Things that you might do wrong that you apparently did not do wrong in this case.
Well, I was kind of curious about, like, if we're doing a PA2, and even though I did really good in the last one, I could somehow make a slip where I think, oh, well, if I play this for PA2, all of a sudden I am marking points out because either I didn't comment or something like that.
Yeah, so we'll talk about PA2 shortly, and I have a grading rubric in there, and it includes comments about comments, and coding style and things like that. So we'll see, what the expectations are for PA2. But in general, right, if you're scoring well on the assignments and you're not getting, feedback at all, or feedback that's talking about things that you should do differently, just keep going the way you've been going, and follow, whatever additional things we add in class or in the assignment. But it's mostly things like, if people had a try block with several lines of code in here, I might have given a comment saying, make sure your try block is only used around the thing that might fail. I didn't take off points this time, but I would take off points in the future, that kind of thing. But if you got 100 and no feedback, you're doing the right thing. You're following what you're supposed to be doing, and you're probably in great shape. So just keep doing it.
I appreciate that feedback.
Okay, you're welcome. Let's see. So any questions on PA1?
I do have a question in my mind that I was thinking of. When you make a class and you call the class, is the very first thing that the program wants to do is execute the constructor in that class?
So when you construct a class with a new keyword, the constructor gets called, and you can assume that that one of your constructors will get called before any of the other methods get called, except for static methods. Because if you don't construct an object, you can't access any of the methods. So you're pretty safe, if you have some initialization you need to do, you can go ahead and put that in your constructor, and you're pretty safe that that's going to happen before anything else happens.
Well, I was thinking, didn't you actually make a constructor the same name as the class? So that way it will get executed when you call that class? Was that kind of the idea, or what was the reason for the same name?
So terminology, right? You don't actually call a class. You can construct a class, right? But inside a class, the constructor is required to have required to be a method, basically, with the same name as the class. But it's not actually a method. It looks like a method, but it doesn't have a return type. So let's take a look at some example code. Let me hop over here. So this is similar to what most people had, although some people managed to do this in very few lines of Java. So here's an example of the MyStack class, right? So class MyStack, so that says, hey, you know, everything that I find between this curly bracket and this one is part of this class, right? And there's kind of a global inside the class, or a property, right? This is the thing that represents the stack. Okay, here's the constructor, right? The constructor is basically a method with the same name as the class and no return type specified, right? That's how you say this is the thing that should be called when I say new MyStack with no arguments. Why is it this? Because this has got the same name as the class, right? So that's what a constructor is. Does that make sense?
Yeah, it's another way to kind of basically, like when you basically create a, well, let's say create a variable, but basically create a variable in the main program. This class will construct it, so that way it's ready to use. That's kind of the idea, correct?
Mm-hmm. So to use this, when I say MyStack stack equals new MyStack, it's this new MyStack business that's going to cause all of this code to get executed. Everything in this thing called MyStack.
Yeah.
Right, so the terminology is this is a constructor, and this is constructing an instance of this class MyStack, and it's saving it in this object called stack.
So when you say new MyStack, when you call new MyStack, that's calling the constructor?
Exactly, yep.
Okay.
So that's calling the
That makes
constructor.
that makes a lot of sense. Because you say MyStack equals new MyStack, I was like, that's kind of like saying old orange equals new orange. Kind of like.
Yeah.
It didn't make sense at first until I realized, yeah, that's what you mentioned about it's calling a constructor that's inside of whatever class it's stored in.
Yep, exactly.
Except it has to be the same name, so I'm pretty sure we're going to be like, oh, you're referring to my class.
Okay.
Or my stack class. And
Mm-hmm.
I don't know. I'm more thinking that, but I was just like, I like to get the details.
Yeah. It's a pretty critical detail, and like many things in programming and in life, you can get pretty far without understanding it too deeply. But personally, I like to go back to those things over time and try to understand them more precisely in a way that makes sense to me, right? And if it doesn't make perfect sense to begin with, you can still move forward with it. But something in my brain will keep saying like, hey, what about that constructor? You know, why does it look like that? And I'll keep going back to it and eventually, you know, make peace with it. So yeah, there's the declaration of the class. Here's the linked list which stores the stack. Here's the constructor, and the constructor takes no arguments, and it simply constructs a linked list of integers and saves that linked list in this object called stack. The toString method, I'm just returning stack.toString. The pop method, I just remove the first element from the linked list. The push method, I just add a first element to the linked list. And the isEmpty method, I just check to see if the linked list is empty. There's no good reason to have a usage message inside here, because that's not part of the stack class.
Yeah, I think what I did for my PA1B is I added a method that just prints out a help message.
Mm-hmm.
Which can make things a lot more cleaner since I don't have to like post it in my while loop.
Right.
So that makes it look like a mess.
So yeah, in my main program for usage, I just have my help message here. which I can print out in the very beginning before my first prompt, and I can print out when the person says question mark. And this I just forgot to delete it from the end of the class, so ignore that. That's not there. And then my queue, same idea, but it's called queue, but it's still a linked list. And the only difference is when you insert, you add it to the end of the list. Other than that, it looks like this. Looks like the stack.
So it's kind of like curiosity. Can you make a linked list of structures like we did in C?
Oh yeah, we're about to. That's PA2.
Oh well, sorry for the spoiler.
No problem.
I thought something curious, like, I don't know, I'm pretty sure, in other words, object-oriented programming, the idea of making linked lists is kind of the same throughout languages, correct?
Mm-hmm.
It's not just specific languages, it's like universal.
Right.
Kind of.
And linked list is an abstract data type, right? It can be a linked list of almost anything. And we've seen when we create linked lists, we can specify what kind of object we want to be in each node of our linked list. And this has been an integer, it could be a string, it could be a rectangle, it could be, anything that we imagine. Could be another linked list. Alright, so main program is just 224 stuff, right? So there's a stack mode variable to say if we're in stack mode. There's a scanner from standard in, print a help message in the beginning and a prompt, and then a main loop as long as we have more input. Ingest the input, so this reads one line. If it's an S, set stack mode to true and print out the top of the stack. And again, I'm just printing by outputting TOS plus stack. Otherwise, if it's a queue, set stack mode to false, print out the contents of the queue, and that's the end of the S command. If the command is X, we want to exit, so I'll say goodbye, and I'll just do the hard exit right there, system exit 0. If the line is empty, then I want to see the contents of the stack or the queue, so I do all of this, which says if you're in stack mode, see if the stack's empty. If it's not, pop it and print, otherwise say stack is empty. If you're in queue mode, see if the queue is empty. If it's not, do queue remove and print, otherwise say the queue is empty. So that's all for an empty line equal to quote quote. If the input is a question mark, I'll print a usage message. Otherwise, I assume that they're typing an integer, so here we have to do some testing. So I declare my integer num outside the try statement, and then in my try, I just say, hey, let's try to parse our integer. If I get an exception, I will come down here. Most people did illegal argument exception, which is great. Illegal number format or something. That's great. I got lazy. I just said exception. If there's an exception, I'll print out illegal number, I'll print out a prompt, and I'll say continue, which takes me back to the top of my while loop. Otherwise, when I come down here, I've executed this parseInt. Num is my integer. If I'm in stack mode, I'll push. If I'm in queue mode, I'll insert. And then I'll print out a prompt to go back to the top of the loop, which is right there. So pretty much the same setup as PA1A. Main difference being, things like this instead of stack push, stack comma num. We use push as a method in the stack object.
I do a mental thing. When you're like grading my work, did you see that I made like a little message for anyone that did like a Control D to hashmap program?
Mm-hmm.
As like a little Easter egg.
Yeah.
I thought it was pretty cool.
Yeah, definitely.
I remember that. I don't know if anybody else did that, but that's what I did. I put down like I was expecting you to press Enter X, but I'll exit the program anyways.
Mm-hmm. Right. So in this case, we had an X command for exiting. But it's always good to define what should happen if we hit end of file on input. So if the person hits Control D, or if you were redirecting input from a file, and the last command in the file is not X, well, this has next line will fail, and it'll say, hey, there is no next line. And so in this case, it comes down here. So you could put some other message in here, like, you know, goodbye or whatever. Zoom fun, always a good time. But looks like you're back. All right. Any other questions, comments on PA1? All right. Well, on to programming assignment 2. All right. This is a biggie. But do not panic. All right. So we're going to play with linked lists and hash tables and strings. And in particular, we're going to be pushing this idea of, you know, everything is an object. And a linked list can contain anything we want. And a hash table can contain anything we want. And so we're going to combine a number of different types of objects. We're actually going to make a hash map that has key values of strings and data values of linked lists, and those linked lists are going to contain integers. And we're going to put all of this together to do a word index program. And the goal of the word index is to basically let us take a file and create an index of it. So, you know, a textbook, if you look at an index, it's a list of words in the back of the book, and it has a list of page numbers where that word appears. So you get a textbook on Java and you want to know where it talks about linked lists. So you go to the index and you look up linked lists, and it'll say it's on page, you know, 2, 12, 219, 1542. And those are the pages where that word appeared. And so we're writing a program here that will basically create a word index for us. And instead of page numbers, it's just going to tell us what word number, starting with, you know, the first word of the text file, where each occurrence of a given word is. And so let's do some sample code. So first thing I will mention is testing. So there's some test files available for you on the server under /tmp. There's pa2test.java, testfile.txt, and indexer.class. What you're creating for this assignment is your version of indexer.java, which compiles to indexer.java.class. Alright, so I'm copying these from /temp into my local directory. And this is just a sample test file. Let me change this. Let me make a new test file. Simpler test code. I haven't tried this before. This will be fun. All right, so you're going to create a class called indexer. And the whole idea is you can construct an indexer, and then you call the process file method. You give it a file name, and it should go through that file and count up how many times each word occurs and where each occurrence of each word is. And I can call number of words and see how many unique words there were in my file. And there's other methods that I can call also, but I should also be able to print just the index itself and get a list of words and where those words occur in my file. So let me just try this with a simple test file. Let me just call this test2.
I do have a question.
Yeah.
So with your location, are you talking about the line number? Or are you talking about like the number, the word number, like the third word in the?
So the third word, starting with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay.
All right. So here's a exciting story. Hello, this is a test. Can you hear me? Test, test, test. Good test. You can hear me. Goodbye. All right. So let's try this simple test program. If this doesn't work, I'm going to be really embarrassed. So let's compile this. I'm not even going to check my status from here. Alright, so I'm going to run Java main. And it's going to tell me I had 11 unique words. The word appeared in position 4. Can was words 6 and 16. Test was the big winner. It occurred in positions 5, 10, 11, 12, and 14. Right? And so hello was the first word, right? And it told me hello occurred at position 1. This occurred at position 2, which we can see right here. Is was at position 3. Was at position 4. Test, right? It tells us it was at position 5, which is right here. 6, 7, 8, 9, 10, 11, and 12. That's what it found here. And then 13, word 14, it was also word 14. So that's the high-level behavior of your indexer class. It's going to let you take a file, and it'll basically figure out this information. What are each of the words in the file, and what places do those occur in the input file? And it's ignoring punctuation, it's ignoring line breaks, it's converting everything to uppercase. So test with a lower t, test with an uppercase t, same thing. So it's just making that index you could put at the back of a book. So there are a few details making up the 7 pages of this assignment. But you got the basic idea, right? You're going to somehow analyze the contents of a text file, keep track of how many times each word occurs, and build this into a structure called an indexer. Alright, so details. Create a new Java class named indexer. So your upload is a single file, indexer.java, inside a tar file. You're not responsible for writing a main program for this, right? All I want is your indexer.java file. I'm going to run it against my test files that use your class. So again, you're going to have to be very, very precise in what you call your class, what you name your methods, uppercase, lowercase, types of arguments, and so on. Any deviation, and I may not be able to get to your methods from my main programs. All out. Indexer reads the contents of a text file, creates an index showing the location of each word in the file.
I have a question.
Mm-hmm.
So for upload the tar file, but it looks like you only want. So it looks like you want us to submit only one. You want us to submit like one file, but
Mm-hmm.
not like it's a tar file, but it only contains like one file inside the tar file.
That's correct.
It's kind of pointless to make a tar file if you're only having one file inside of it.
Well, it's a good question. So Canvas, when you upload a file to Canvas, if you upload pa2.java, Canvas does not name it pa2.java. Canvas will put your first name, your last name, a bunch of numbers, maybe some underscores, and somewhere in there pa2.java. So if I download all of your submissions from Canvas and I drop them into a directory, every file has a different name. And if I just compile, your file with a java c star.java, if that name does not match the name of the class, I'll get a compile error. So now I have to figure out what Canvas named your Java file. I have to rename it to pa2.java, and then I have to Java C that. And I have to do that, 30 some times. So a tar file, I don't care what it's tarred. I can just say, tar xvf star.tar, and whatever the tar file is called, it'll wildcard. But the thing that comes out of it will be pa2.java exactly. And then I don't have to rename it in anything.
Okay. Yeah, really, Canvas does that, but. Okay.
Oh, Canvas does all kinds of things, you know that. But more generally, right, a tar file is a way to treat the thing that you're handing someone as an envelope. Right? If you're giving someone a check in the mail, you could put it in a 5-inch envelope, you could put it in an 8.5-inch envelope, you could put it in a manila folder, right? And they don't care, they just want the check. So the tar file is really just the container that you put the thing inside. But if I put the check in the mail, it's going to get a postmark on it, it's going to have a stamp in the corner, and when the person tries to cash it, the bank's going to be like, hey, what are you doing? This thing has a stamp on it and a postmark, and it's been rained on.
I'm kind of curious whether or not. So I guess are tar files considered like traditional file type for like handing this to another programmer or to a business and so forth? Is it kind of a traditional way, or not traditional, but like the official way of doing it?
Mm-hmm. It's pretty standardized, and traditionally, tar was a tape archive. I don't know if that'll say it in here. So there's a program called AR, which creates, modifies, extracts from archives. And that's a way to bundle a bunch of things together into a single file. But magnetic tapes used to be popular enough that there was a special version of tar just for dumping things onto or taking things from magnetic tape. And so that's tar, it's a tape archive. And then, you would take this physical magnetic tape on the spool and you would carry it over to another machine and put it on the machine. You could read the data off of there. And so this is how you could transfer files from one machine to another. Same thing we're basically doing now. You should be able to do java-class path to test your code. That should work fine. But you may want to modify the main program because it's pretty wordy and chatty right now. So you can copy it into your own directory. But yeah, if you want to just run that code verbatim from /temp, you can use the CP switch. We'll talk about class paths in this course later, but it's a little far afield for right now. Alright, so continuing PA2. similar to PA1B, your goal here is to work smart, right? Your goal here is to think about what's available in the hashmap package or the linked list package or the string class. What's available in those and how can I use those? And you should not have to do a whole lot of writing complex code for this assignment. You should not have to, write a hash function. You should not have to deal with collisions. You should not have to deal with a node and move to the end of a chain of nodes and back up one step and use a previous next and so on and so forth. All that stuff that we did in 222 is behind us, right? And we want to take advantage of the fact that there is a linked list class, there is a hash map class, there is a string class. We want to use what's available in those. Those are big classes. They have lots of methods available, lots of power in there. We want to capitalize on that. So this is where I say, right, we're thinking about objects as self-contained entities that have code and data in one spot. And as soon as we have a linked list, we have a way to add things to it. We have a way to search it. We have a way to print it, right, without doing any work. If we have a linked list and we want to add something to the end, we can just call the add method. If we have a linked list and we want to change it into a string, we can call the toString method. So we're going to make a hash map where the data values are linked lists, which means once we pull a data value out of the hash map, that thing that we have is an object. It has code. If that thing is a linked list and we want to search for something in it, we can use a search method from the linked list class. So this is a lot about thinking about what you're going to do before you start writing too much code. And so for reference, my entire indexer class came out to around 84 lines and only about 40 lines of actual code. Half of those lines were just formatting. Empty lines or just, lines with a curly bracket or comments. So think a lot about this before you start coding. And if you find yourself writing hundreds of lines of loops and if statements and recursion and all this kind of stuff, take a step back, because you're probably doing work that's already been done for you. Alright, so think about what you're going to do, how the code will be structured, how the different parts work together, and so on before you start writing too much code. Alright, again, stay away from Eclipse, IntelliJ, Visual Studios, things like that. Stick to the command line. Okay, we'll switch to Eclipse for PA4 and 5, but for now, stick to the command line, Java C and Java. Right, it will help when you get to exams and you're trying to write this stuff on paper. If you've been using an IDE, you're not going to have any idea how to write some of these things. So, type it out by hand. It's time well spent. Alright, so you're developing a class named Indexer for your own work, for debugging and developing. You're going to want to write your own main program or multiple main programs to test your Indexer class as you develop it. But your only submission is indexer.java. Alright, it has a constructor which doesn't really do anything. So you don't even have to write the constructor, right? There's always a default one. But if there's some initialization you feel like you need to do when the class is constructed, you can do that here. But most initialization is going to want to be done in the process file method. Alright, so you have the following public methods. Process file, this is the real workhorse. Right? And typically to use the indexer, you construct an indexer and then you call process file. And process file should open a file, read the contents, and build up this index as it reads it. And really important, you got to build the index while you're reading. Don't read the entire file into memory and then process it. Don't build one string containing your entire input file and then process it. I'll be running this on War and Peace, Wuthering Heights, some other big documents, and it's going to cause your code problems if you're trying to keep everything in memory. So process as you're reading, and you can actually read one word at a time and process one word at a time. Yeah, go ahead.
we're gonna put a file name, I want to know what you named your text file.
That's the argument that you specify in the process file method.
So I was saying what name, like what you put their text file like test or test2, like I might come to an error where it says not find file name.
So if you want to process test.txt, you would call process file quote test.txt.
So I was saying are we gonna assume that are we assuming that it is called test.txt and not have to worry about any changing any random file text files?
Nope, you don't need to assume what it's called because you're going to be told what it's called, and that name is going to be in this argument called file name, which is a string. So whatever you do inside your process file method, don't do it to test.txt, do it to file name. Right? This is not a main program. This is a class like linked list or string or hashmap or rectangle. It's a class called indexer. If you wanted to actually index a file, you would make a main method. You would create an indexer object, and then you would call that indexer object's process file method, and in there you might say process file quote, mytest.txt. But the code inside this method is just going to see, hey, file name, that's the name of the file I should open. And it'll pass this as an argument to the way we're going to scan from a file.
I see. Thanks.
It's a good question, and if it comes up again, think about it some more or ask again, because it's sort of one of the key ideas of making a class versus a program, right? And it's a really powerful idea, this notion that what we end up with will work on any file, right? Not just testfile.txt, but we're going to specify the name of the file as an argument. So keep thinking about that and keep asking if it stops being clear. All right, so process file. This is usually what you call after you construct an indexer. If you don't call process file, these other methods don't do a whole lot. So mostly we construct an indexer, we call process file, that sucks in the file, builds the index, and then we use these other methods to see, what happened when we built that index. So what happens in the process file? It opens the file, it reads its contents using has, next, and next. So this will read one word at a time, where words are things separated by spaces, right, including new lines. While it's reading, it builds an index. And it does this by cleaning up the word, getting rid of punctuation, making everything uppercase, seeing if it's seen that word before, and either bumping up, the tally, or adding it to the list of words, and so on. All right, and the whole thing returns a Boolean. If it succeeds in indexing the file, it returns true. If anything goes wrong, which usually means, it couldn't open the file to begin with, it should return false. And it operates silently. I can call process file 1,000 times with 1,000 different file names. Some of them might exist, some of them might be non-existent, some might be protected. It should never print anything. I should get no output from the process file method. If something goes wrong, all you're going to do is return false. Right? If this produces any output to standard out or standard error or anything, you'll lose points. It's a silent operation. So try to open the file, read it in, build an index. If something goes wrong, return false. If nothing goes wrong, return true. Now the person who calls this might very well say, hey, if this returns false, let's print out 25 error messages. That's fine. That's the caller's choice. But the method itself acts silently. So it doesn't print anything. It just returns a flag. All right, if it returns true, now you can use the indexer object to do various queries on what it discovered when it indexed the file. So one method we have is number of instances, and that takes an argument which is a word. So I can say number of instances, quote, test, uppercase, and it'll tell me how many times it found that word in the index. If process file has not successfully run, this should return -1. That's a flag saying, hey, I can't do what you're asking. Otherwise, it should return an integer bigger than or equal to 0, telling me how many times this word appeared in the input.
If process file returns -1 and we print out an error message saying that it's not been successfully run.
Where would you print that from?
Main program.
Main program is your doing. You can totally do that. Just don't print it from process file. But yeah, typically, if you were writing the main program to drive this, you would check the return value, and if it's false, you'd print some kind of message saying, you know, I can't open file name, or I can't process file name, or something like that. And then you would probably go back and say, you know, try again, or you could exit, or whatever you like. But again, main program is strictly for your benefit to test your indexer class. I'll have my own main programs that I'll use to test your indexer. So what you do in the main program, totally your choosing. And yeah, that would be a good thing to do, is check that return value. If it's false, print an error message.
I'm assuming that nothing in this class, the indexer class, nothing in there is supposed to print, correct? It's just only to return a value or return.
I think that's probably true. I don't know if I say that in here, but I think that's probably true. I don't think any of these things will ever print.
I'm assuming that the main program does all the printing
Mm-hmm.
and saying that and all that stuff.
Yep.
It's pretty consistent.
Yeah.
But I'll make sure, because if I'm working on this, I want to make sure that, like, oh, am I supposed to print this out? Am I supposed to do this?
Mm-hmm.
Instead of printing, I should just return it.
Yeah, I think all of these are just going to return. Alright, so if this returns false, but I go ahead and I call number of instances, return -1. It means, hey, I can't count the number of instances for some reason. But assuming that I did succeed in processing a file, this should tell me how many times this word appears. So you're going to need some flags, right? At the end of process file, if you succeeded, you're going to have to set a flag saying, hey, I did process the file, so it's okay to you know, return the number of times here and so on. Alright, so this tells me how many times word appears in my index. Location of takes a word and an instance number. And so this says, you know, tell me where the nth occurrence of this word was. So if I have instance number of 0, that says tell me where the first occurrence of this word is. If I pass an instance number of 1, that means tell me where the second occurrence of this word is. Right, so first occurrence is 0, second is 1, and so on. And again, if I haven't succeeded in processing the file, return -1. If the word does not appear in the processed file, return -1. If the instance number is too small or too large, return -1. So this is your error message, right? The location of each word should be 0 or greater, right? So -1 is a flag.
I'm kind of curious now that that we're relying so much heavily on process file, are we making it like, I was gonna say static, but I don't think, we're not using static. Instead we're, I don't know, like, how are we gonna, are we just gonna make some kind of variable,
Mm-hmm.
and then make a global variable, because that way that all the functions be
Yep.
able to, or methods rather, would be able to access the process file state.
Exactly. So in the beginning of your indexer class, you'll have some kind of Boolean, you know, process file succeeded or something like that. Initialize it to false. And then inside process file, if you succeed, set that Boolean to true. And then all of these methods, first thing you check is that Boolean. If process file succeeded is false, return -1. If process file succeeded is false, return -1. And so on. and it's a part of the class, which means, you know, I can run indexer. I can have 5 different indexer objects run on 5 different files, and they're totally independent of each other. The success flag in one is independent of the success flag in another. Right? Because it's part of the object. It's a global in some sense inside that object, but it's peculiar to that object. And this is where a static will get you into trouble. If you tried to make it a static, it becomes kind of global across all the instances. And so just don't do that. All right, number of words just tells me how many words it found, how many unique words it found in the index. And that should be, you know, 0 or greater. And so if something went wrong, if we couldn't process the file to begin with, return -1. And then toString should give me some output that looks like this. So curly brackets, and inside, comma separated list of words with the word followed by an equal sign, square brackets, comma separated list of locations where that word occurs. You do not have to do any work to make this happen. This is the output of the toString method of your hash map. So it says in here to return the toString value of your hash table. That's all you got to do, and it'll come out with that glorious format with all of this information in here.
Wait, so is each flag index? Is these words considered stored in index better than 0? So like index 0 would have A with a count of like 4.
So this is the word number where each word occurs, starting with word 1, 2, 3, 4, 5. So hello is at position 1. This is at position 2. Is at position 3, and so on.
But I'm saying that it's not in order though.
It's not in order, no.
So how does it actually store it inside of a hash table out of order?
Oh, hash tables are rarely ordered, right? Hash tables are ordered based on the hashed value of the key. If we build a hash table with an array, and I have an alphabetized list of words, they're probably not going to come out in the same order inside the hash table. That's okay with us. And you're not required to alphabetize the output. And in fact, I don't want you to alphabetize the output. I want you to simply take the toString method of the hash table and give me that. And then my test and your test should produce the same output.
So if we're gonna put this in toString method, all we have to do is just return the hash table variable?
Mm-hmm. Hash table.toString, or hash table plus ... Okay. And seriously, most of these are going to be, you know, 1 or 2 lines of code. The longest method of your whole program is probably going to be the thing that cleans up the input word, converts it to uppercase, gets rid of punctuation, and so on. And that's going to be a loop with, you know, maybe 3 or 4 lines in it. And most of these are going to feel like PA1B. They're going to be wrappers around other things. And we'll see how as we dig deeper into this. I keep forgetting to put my countdown timer on here. I've been recording this lecture, but I forgot to put my little timer bar up there. All right, so you should implement the following private methods. These are for use inside your class. And you really want to implement these methods, because these will make the rest of the work much easier. So 2 methods. One is called cleanup word. And cleanup word takes a string and gives you back a string. And to do that, you basically want to get rid of punctuation, convert everything to uppercase. And there's a static method in character called isLetter. And you can say character.isLetter and give it a single character, and it will return true or false to tell you whether or not that character is a letter. So you're going to dig into the string class a little further. And for example, if you have a string word, well, we can use various methods on Word. For example, we can say word.length, and this is the number of characters. We can say, well, let me just bring up the documentation. We can say word.character at, so character at takes an index and gives you back that character. Now in C, these things are just arrays, so we can just say, you know, word bracket, but they're not arrays in Java, they're objects. So we can say word.character at I. This gives us the ith character. And this will be something between 0 and the length minus 1. So if you find a word like this, word.length will be 6. Word.character at 0, 1, 2, 3, 4, 5 will be those 6 characters. So we can make a loop from 0 up to length minus 1. And we can get the ith character using character at. And so, you know, you could say something like, you know, character C. And then we could say if character dot, and we're only required to use letters. So there's an isLetter method. So we could say if character dot isLetter C. Then we want to include this character.
It's just for the wrong tab.
There we go. So if character.isLetter C, then we want to include this character. And so how do we do our conversion? Well, you know, start off with an empty return string. For I equals 0 to the length minus 1, if the ith character is a letter, then return string equals return string plus the ith character. And then return the return string. So that's pseudocode, but it's the same thing in Java basically. So that's a for loop up to length paren minus 1. How do you know if the ith character is a letter? Check if, you know, word character at I, feed that as an argument to character.isLetter. If it comes back true, it's a letter, in which case concatenate it to your return string. And at the end, just return string. So if your string looks like HELLO exclamation mark like this, the return string would be this. 5 letters, all uppercase. The exclamation mark get dumped. If my input string is something like 1, 2, 3, my return string will be an empty string, quote, quote, because none of these are letters. And so I never concatenated anything to my original return string, and I'm just returning an empty string. So one's... Go ahead.
So when they say length minus 1, does that mean that if we use, when you try to use word.length, it will like include a null terminator?
No, it's an index 0 issue. So this is character 0, 1, 2, 3, 4, 5. The length is 6. Length tells us how many characters are in there, but when we use character at, we start with 0 for the first character. So the 6th character would be the character at 5. So it's this usual -1 business because we're indexing from 0. But it's nothing to do with a null terminator or a new line at the end in this case. This is basically like accessing an array. So if you make an array and the array has length 10, the index of the last element is 10 minus 1, 9. That's all that's going on here.
Okay. I mean, I should have known that, but I was kind of, I thought it was like similar to C.
Same idea with arrays in C, but with C, because we have this null terminator, that starts to look like part of what's going on. Like the length tells us the location of the null terminator. Not related to Java though. Alright, so cleanup word takes a string, returns a string. Be aware that the return string could be empty, right? If you give it a string that does not have any letters, the return string will be empty. So we need to check for that. So add reference is your other private method. This should take 2 arguments, a word and a location telling me where that word occurred, and it should add that word to the index. So this does really all of the work that process file is doing. Right? This is the thing that will create a new reference for a word, and we're going to put it in a single method called add reference. Give it a word and a location. And so here's what's going on. You're going to build a hash table.
I can wonder about is there a hash table method object that is there a hash table like method that tells you the size of the hash table based on the size of the file?
Oh yeah. Well, not based on the size of the file, but based on the size of the hash. So,
also if you want to determine how many words you put inside of the text file, that it will really affect your hash table. Because
yeah,
if the
definitely.
Hash table is smaller, if the hash table is smaller than the amount of words, then you might throw some kind of, I'm going to assume it's probably a cycle.
Nope, you don't have to worry about it. So that's a 222 concern. That is not a 223 concern, because this is a super whiz-bang hash map that's provided for us, and they will actually grow dynamically. And you can actually specify how full you want it to be before it grows. And when it grows, it happens silently in the background, right? So there's an initial capacity and a load factor. And capacity is how many buckets, so that's like the initial array size. And the load factor is how full it can get before that size is increased. But that all happens in the background for us, so we're not going to have to worry about it. And if we want to know how big the hash table is, there's a size method. It tells us how many key value mappings are in the map. And if we want to search for a key, we can call a contains, right, to see if it contains a particular key or a particular value, and so on. All right, so here's the setup. We're going to have a hash table. It's going to have keys, which are words. So this, and test, and hello, and so on. And each of these is going to be a linked list. So if the word this appears at position 2, this is going to be a linked list containing 2. If the word test appears at positions 5, 10, and 11, this is going to be a linked list containing 5, 10, 11. And we're going to build up these linked lists associated with each word we find in our file. So this is how we're going to store our index. We're going to build a hash table. Each word we find in our input file is going to be a key to our hash table, and the corresponding data is going to be a linked list of locations. Does that structure make sense? So add reference is a method that takes a word and a location. So suppose I call add reference hello, 20. The end result of that should be 20 gets added to the end of this linked list. If I call add reference by 21, the end result should be, hey, the word by is not in my hash table, let's add that. And let's make a linked list containing just that reference 21. If somewhere down the road I find the word by again, it'll say, hey, there's already by here, let's add the next reference to the end of this linked list. So when you're done with the whole file, you've got this list of words and a list of locations where each word occurred. And so this is one of these examples where you really need to understand what your goal is. If you're absolutely clear what it is you want to have happen, then writing the code to do it is going to be pretty simple. The biggest challenge perhaps is understanding that this is a hash table and my keys are strings and my data values are linked lists, and my add reference method should take a string and either find it and add to the end of that linked list, or add it and create a new linked list containing that reference number. So one of two possibilities. And then doing those things are typically, one line of code each. All right, and add reference, if you haven't processed a file, don't do anything. Right? That would be a error on the main program's part to call add reference before, successfully indexing. Yeah,
There's
before.
no file in process. You're talking about just ignore or don't assume that the main program is going to call this function without being processed.
So this is never going to get called by the main program, actually. This is a private method. This is going to get called by your process file method, right? Which means that, you've opened a file and you're starting to read it. But if for some reason you wrote code that called add reference without having actually successfully opened up a file, right? That's makes no sense. There's nothing you can do here. Just return. Don't do anything, but don't throw an exception. So this would typically happen if you hadn't created your initial hash map because your process file failed or something like that. So just make sure this doesn't error out. But you're the only person calling this, right? This is private to your class.
Okay.
All right, you only need one field in your entire class that's named index. An index is a hash map. We're going to look at hash maps after a break. So you have one field named an index. This is like, stack in the MyStack class. Your field is called index. It's a hash map. All right, so how do you do all of this? Process file is the entrance way to everything. So what happens when you call process file? Open the scanner to read the file, and we'll talk about how to do that. You have to do one modifier on the scanner constructor. So open a file, create an empty hash map called index, and the keys should be strings, the values should be linked lists of integers. Have some local variable, right? This is inside process file, so you have some local variable, your position counter initialized to 0. read a word using scanner.next, right? Do this as long as hasNext is true. So read a word using scanner.next. Clean it up using cleanup word. Make sure the word's not empty. If it's empty, don't do anything. Go back to the top of your loop, pick up the next word. Because the word was something like 1, 2, 3 that had no letters in it. But assuming the word's not empty, add 1 to your position counter. That's the position that that word appeared in the file. Call your add reference method to save it. And just do that in a loop until end of file, close the scanner, return true. So process file doesn't actually do a whole lot. It calls cleanup word and it calls add reference. And that's really it, right? It uses a scanner to read things in 1 word at a time, calls cleanup word to make the word uppercase, calls add reference to add it to your hash. At the end of the file, close the scanner and return true.
Is there a method inside of an object that determines whether a word is not empty?
You can just check its length to see if it's 0.
Oh, okay.
Yeah.
Just like, it's a very dumb question, but I thought I was like, what do you mean by word is not empty? Like,
So you could see if its length is 0. You could see if it dot equals quote quote. I think there's an isEmpty method you can call in string, but this is the same task as in PA1, right? Deciding if the person just hit the enter key without typing anything. So any of those ways will work, and there's a lot of different ways to detect that.
so this is assuming that there's only like a punctuation and nothing else, or numbers.
Mm-hmm.
Correct?
Yeah, so if it's a string like 1, 2, 3 in your cleanup word loop, none of those will look as letters, and so nothing will get added to your return string, so return string will be quote quote. It'll have a length of 0. If you don't do this, all that happens is you get a bogus entry in your hash table for empty words. All right, so this is the sense in which add reference does, the real work, but process file is the main thing that you call. That's the entryway to the thing that does everything. All right, and then sample main program, pa2 test.java. And this just exercises the index class. But like I say, as you're developing this, you probably want to do your own test files along the way. But this is one of the main programs I'll use to actually test your submission. So I create a new indexer, and then without calling process file, I'll try printing out the number of instances. I'll try looking for the location of test. I'll try finding out how many words. And all of these should not blow up. They should just return, their flags saying that we haven't processed a file. And then I'll try processing a bad file, and I'll look at the return from process file, which should be false. And index should just be probably null at this point. Or the toString method should just come back with an empty list. And then, these should throw the flag of -1. And then I'll process a good file. Status should be true. This should show me the nice clean output, from the hashmaps toString method. Bad is not in the test file, so number of instances should be 0. Test is in the test file. It should tell me how many times. And then I'll print out how many... print out where each occurrence of test was, starting with -1, which should return -1, and going up to a number that's too big, which should be -1, and the values in between should show me the locations and then the number of words. That's just a sample main program, and there's a sample test file that will drive it. And here's what the output looks like. So you can do that for kind of a final test, but you probably want to do your own test programs along the way. All right, let's do a 5-minute break, and then we'll come back. We'll talk about grading. We'll talk about suggestions for how to approach this, and then we'll start digging into hash maps. So let me tag a break here, and let's do Let's do a countdown until 11:26. So I'll see you back in about 5 minutes. All right, we're back. Grading rubric for PA2. This is not all inclusive, but these are the highlights. So submit your file as a tar file, pa2.tar. Should contain a single class file named indexer.java, and ideally that's all that's in there. I'll be recompiling it myself, so you don't need to include the class file. Don't need to include test files and so on and so forth. I'm just going to use your indexer.java, compile it to a class file, and then run it against my main test programs with some various input files. So some points to consider. If I can download your submission and it compiles correctly, you're guaranteed at least 20 points on this assignment. It's a 100-point assignment, right? If I can't do that, you'll get anywhere from a 0 to an 80, right? If it's something simple like your class name was misnamed or something like that, you'll lose 20 points, but I'll continue working with it. If it's munged up, if it's not submitted, if the tar file is corrupted, if it's PA1 instead of PA2 or something, right? Then it's at least 20 points off, all the way down to possibly a 0. Got to have an indexer class that's worth 5 points. Process file should ingest the given file and store at least some cleaned up words in a hash map. That gets you 10 points, right? If nothing else happens, if it's not tallying the words correctly, if it's missing some words or things like that, you can get at least 10 points just for reading in the file, cleaning at least a few words and storing them, right? But hopefully you're reading the entire file and storing all the words. Process file associates a linked list containing at least one location with some of the words. That's worth 5 points. If for some reason you do this, but your linked lists only contain a single word each, right? You still get a few points just for having words and linked lists associated to each other. If it manages to save all of the words in a linked list with some of the locations, that's worth 5 points. If it manages to save all the words in a linked list with all the locations, that's worth another 5 points. So this is kind of a rubric built up around how you might go about developing your code. If you don't want to just sort of write the whole thing and then compile it for the first time, you can develop it in pieces, right? So these are increasingly functional pieces. All right, and the other methods: toString, number of words, number of instances, location of, 5 points each if they are perfect. If they're imperfect, you don't get any points for that method. All right, correct handling of when process file does not run successfully, right? So you have some flag that lets you know that, so that it doesn't do something it shouldn't do. That's worth 5 points. Those 2 private methods are worth 10 points total, right? So you got to have those private methods with those prototypes and so on. And then 15 points for style. And this is broken into 3 points. So got to have your full name, class number, and the date in the beginning of indexer.java. The majority of submissions I got, no name on them, right? So you got to have your name in there. That's worth 3 points. University is worth 100 points. So we'll build up to that, but make sure your name is in there with CSE223, spring 2022, and the date. The entire class, the indexer class, should have a block of comments in the beginning that describe what this does. Don't copy and paste from this assignment, right? This is the indexer class. It allows you to process a file and record the number of the location where each word occurs. This is done by making a hash list with hash map with keys of strings and data values that are linked lists of integers. That's sufficient, right? Just what the heck is this thing that I'm looking at? It's the executive summary. Only has to be a few sentences. Consistent indenting, placement of braces, etc. That's looking great on people's submissions, so just keep up the good work with that. I want comments on pretty much every line, right? Most of your methods are going to be 1 or 2 lines of code. If your entire add reference method is a single line of code, you darn well better have some comments saying what that line of code is doing, right? and the majority of submissions I saw, no comments, right? No comments in the stack or queue class for PA2B. Some comments in the main program, but the entire stack and queue class is no comments anywhere, and that's an issue. So plan on commenting pretty much every line of code. Now, if it's a blank line or it's just a curly bracket, you may not need a comment, or you might. But you know, any code that does anything, put comments in there. And then before each method, I want a block of comments telling me what's going on in that method. What does it do? What are the arguments? What does it return? What are the side effects? What are the possible error conditions I should know about? What are the assumptions, right? It's not that many methods. So it's 2 private methods, and then handful of public methods. And I want a comment block in the front of each of these. What is file name? What is the return value? What does it mean if it returns true or false? Right? Is there anything I need to be worried about? If I pass it a file name that doesn't exist, will it blow up? Right? All of those should be answered in that block of comments, not in the code. Right? You shouldn't have to read the code and reverse engineer it to understand how to use this process file method. Number of instances. What if I give it a word that it hasn't seen? Will it blow up? What will it do? Oh, it'll return -1. Put that in the block of comments. Okay. It's only 3 points, but if you don't do any of this, you're down 15 points. Right? That's a whole letter grade. So, best bet, do all of these things. Yeah.
It'll be kind of hilarious if somebody were to make one line of code and have 50 sentences describing one line of code.
Mm-hmm.
That'd be kind of crazy for me.
Yeah. So sometimes, like on a line where I just have a closing curly brace, I'll put a comment saying what that brace corresponds to. Like, this is the end of the main input loop, or this is the end of the condition where such and such happened.
Yeah, I've done that too, because you make a lot of curly brackets and you kind of lose track of what curly bracket corresponds to what block of code you're trying
Yeah.
to do.
And those opening brackets are usually spread out, right? It's like, while some condition, curly bracket, blah, 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 for I equals 0, blah, curly bracket, blah, 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 if such and such, curly bracket. But then sometimes at the end you just have, 5 or 6 closing curly brackets, one right after another, and it's like, what do these things go to, And if your indenting is just a little bit off, it's hopeless to try to match those meaningfully. So sometimes putting comments on there, like, end of if test for empty string, end of for loop that iterates over characters, end of while loop that processes entire input file, that kind of thing. All right, so there's certainly things I have not thought of in here that will cost you points. To get full points, you need to follow, everything that's in this specification. If there's something that you can do that violates the specification, I didn't list it in the rubric, you can still lose points for it. Right? So the rubric is like the minimum number of points that can be deducted, but it could be significantly more. So just do what the assignment says and you'll get 100. All right, recommended approach. So again, right, this is about, planning and strategizing before you start coding. So start with a skeleton. Start with just a bare bones indexer class, right? So what does that mean? Make an indexer class, class indexer, curly bracket, and make a really simple process file method. So what should it do? I don't know. Maybe process file is just going to read a file line by line and print it out, right? Nothing like what you're supposed to do in your final submission. But, it gives you an excuse to write a class indexer, and to write a constructor if you like, and to write something called process file that returns a Boolean and takes a file name, right? And maybe put a try-catch statement in there, so that if you try to process file a non-existent file, it returns false. And if you try to process file a file that does exist, it prints the contents of the file and returns true. And so that's like a very, very bare bones process file method. And then maybe try to change it to print out words instead of lines. So switch from has next line and next line to has next and next. And we'll do some sample code for that shortly. It's not the final method, but you know, it's a really good first step. And you can be working with a test file that has, you know, maybe all of your input on just 2 or 3 lines, everything uppercase, no punctuation, single space in between each word. So we don't have to worry about cleaning up input. Go ahead.
Another question. So is the difference between has next and next? Is the difference is that has next is, well, actually, is it has next or is it just called? Yeah, it's called has next, correct?
So there's a has next method which says is there a next word available, and there's a next method which gives you that next word.
I thought isn't has next supposed to be like reading each like line in the text file?
No, that would be has next line and next line.
Oh, I get that mixed up.
So yeah, we're gonna sample code the scanner in a few minutes, but the scanner has a number of iterators. So has next tells you if there's another token. For us, tokens are just words, right? Has next line tells you is there another line available. Has next int says is there another integer available, or another double, or another float, or another byte, or another boolean, right? So we can do more than just read a line at a time. For this, all we're going to do is read one word at a time, which is a token, which is the has next method. And all of these tell us whether or not a certain type of thing is available. But then next will return the actual token. So where's next? Next returns the next complete token. Next int returns the next int. Next byte returns the next byte. Next line returns the next line, and so on. So they go together, blah and has blah, basically. Alright, so start with a simple test file. Once you're reading in words one at a time, instead of printing them, make a hash map and store the words in there. And don't worry, maybe for a first pass, what you put in the data value. Maybe just store the word and store, you know, an integer or something. But let's make a hash table that contains the list of words, right? And we're not going to worry about what the data value is that's associated with it. So this is just building a hash map with words saved in it, and then at the end of process file, you can print the contents of the hash map. So you can print something like here's my hash map colon and the name of your hash file, which is index. And it should give you a nice comma separated list of unique words from your file. And there's no index information, right? But it will give you a list of the words that appear. And so now you've got half of your index done, right? You can give it a file and it will tell you, you know, here's all the words that I found in it. So now go back and change your process file to actually add a linked list as the data field associated with each key. So when you create a new entry in here, create a new linked list, right? And now go ahead and do the actual word count. And so here's one method where you're going to have to do two things. You're going to need an if statement. Let's say you want to add reference hello. First thing you want to do is go into your hash table, see if there's a key hello. If there is, find the data value, which is a linked list. Use that linked list's add method to add this number to the end of the list. If you call add reference with a word like dog, check your hash table for a key matching dog. If you don't find it, create a new linked list. Store that linked list associated with the word dog, and then do what you did before. Go ahead and use that linked list's add method to add this number 22 to the end of it. That's the whole add reference method. It's one if statement and one call to an add method. So search for the word in the hash, and if the word is in there, use the existing linked list to add your number to the end of that list. Or if the word's not in the hash, create a linked list, store it in the hash with that word, and then go ahead and add the reference to the end of that list.
So, just kind of want to think about searching for a word. Do you want to make this like a for loop to search for each indexes, like order n?
Far too much work.
Or is there a way you can actually search for in a key inside of a hash table without having to do a loop?
So you can say get, and you can pass a key, and if it finds an entry in there, it'll return the corresponding data. If it does not find the entry, it'll return null. So if get parentheses word equals null, you know the word's not in the hash map.
Oh, yeah, okay, so with that v, the return value is the v. What does the v mean?
So hash map is generic, so we're going to have to specify when we construct it what type of thing is the key, what type of thing is the data value. So k is the type of thing for a key, which will be a string. V is the type of thing for the data value, which will be a linked list angle bracket integer. And we're going to do some sample code for that too, probably Wednesday. All right. And then go ahead and make a word counter and use that to add to the end of a linked list. And then you can read through the rest of this, right? But that's, at that point, you've got most of your program done. So now write the cleanup method to convert your characters into uppercase, get rid of punctuation. Add the other methods, which are just wrappers around, if you want to know how many things are in the hash map, it's just using the size method and so on. Write a toString method, which just calls hashmap's toString method. Check for the edge cases where, an index is out of bounds or you haven't initialized your code and so on. Add your comments and so on if you haven't been writing them as you go. Do your final testing, right? Upload your tar file, download it, untar, compile, run your test cases, and so on and so forth. So let's get to some code because I want you to have enough code to get up and running. All right, so the first thing is reading from a file. So we're going to need our scanner package again. And we're going to need a java.io.file. Lowercase io. All right, so let's open a file for reading one word at a time. So I'll make a scanner called file in. And I'm going to have to put this in a try-catch block. File in equals new scanner, parentheses, new file. And I'm just going to hardwire this for now. I'm just going to call it data.txt. And I can get some different types of exceptions here, so I'm just going to catch the type exception, the big wrapper for all of these. I'll fix my typos later. All right, so let's read one word at a time, and let's print out each word with a word number next to it. So this is like half of PA2 we're doing right here. So while file in dot has next string word equals file in dot next. Word number, word num, and let's print out word. And we'll print it out inside angle brackets. And we'll increment our word number. And we're going to want to close our file at the end. And so here's the end of our main method. All right, so this is test code, right? So I'm hardwired it to open data.txt. This would be file name in our process file method. But I'm going to try to create a scanner for reading from data.txt. And so I'm going to pass an argument of new file, parentheses, and then the name of the file name. So a file is just another type of class. And you can construct a file object by passing a path name. And then a scanner can be constructed by passing a file, like this. If I just say scanner parentheses and I just pass in a file name, it'll actually take that as a literal string, and it'll just parse that file name itself. So I have to put it inside a file object. So new scanner parentheses new file parentheses file name. And then I'll use has next to see if there's a word available. If there is, I'll use next to get that word. I'll print it out with a word number. And we'll go with that. Shocking. What did I call this? Data.txt. There's my sample file. There's my main program. All right, so that's sample code for ingesting your file. And if I don't have a data.txt, or if I can't open it, I'll just silently, catch that error. In this case, I printed a message. In the case of process file, we'll just return false. But that's the try-catch business. So this is what you've been doing. Two differences are, one, construct with a new file with a file name, and two, we're using has next and next instead of has next line and next line. All right, so questions about that? Scanner business?
So kind of for recap of what you said, you mentioned that when you make a new file, when we put a new file inside of a scanner, instead of taking all the inputs inside that, basically instead of taking all the words as inputs, you're taking basically the entire file as an input instead of one word at a time.
Nope, you're doing one word at a time. So this whole thing is like an F open in C. So this is basically what's making an object of type file, which is a way to get to a file on the system, and the scanner is saying let's read this in one piece at a time, and the piece we're choosing is tokens or words by calling the next method. But if I did has next line and next line, it would read that file one line at a time. But when this happens, nothing has been read from the file yet. This is preparing to read the file, so it's kind of like an F open in that sense. This is where we see if we're at the end of the file or not, and this is where we actually start to read stuff.
Okay, so if you were just to put the file name inside the new scanner, what would exactly happen? Would it just happen like without, and instead of reading it, it would just like execute as command or something?
So this does something weird. Right, so what did this do? It did not open the file and read it. It basically read from this string data.txt. So it's kind of like an scanf or something like that. So if you want to actually open a file with this name, you have to pass an argument that's a new file with this name. So you construct a file object based on this name, and then you pass that file object as the argument to scanner, and it'll read from that file.
It's kind of interesting because you put a file source inside the scanner argument.
Say again.
You can put a file source inside of the scanner method.
Mm-hmm.
But you're putting it as a string, so that's why it was taken as a string rather than a.
So remember, we have multiple ways to construct things. So we can construct a scanner with a path. We can construct it with a string. We can construct it with a file. We can construct it with an input stream. So system.in is an input stream. New file parentheses data.txt is a file. Quote data.txt is a string. If we created a path from data.txt, we could put that in as an argument, but we would need to construct a path, which we would do with something like, new path, but I think path is just kind of a wrapper for things like file. So it's this idea of signatures of methods and constructors we can construct in a variety of different ways. So for this, all we got to do is remember, make a new file with the path name, pass that as the argument to the scanner. And if you don't, then you just end up with a really uninteresting set of words, and that's the hint to go back and do it differently.
Okay.
All right, let's look at hash maps. So hash map is a built-in class. Remember, hash tables have two things. There's a key and a data value, right? So K and V, key and value. And it's basically associating values with keys. And so your key and values could be any type of object, right? And so for us, the keys are going to be strings, the values are going to be linked lists. But let's just mess around with this. And so this is going to come from java.utility.hashmap. So this is hmain. Alright, so here's what our basic constructor would look like for an object of type hashmap. Hashmap, name of the object equals new hashmap. But hashmaps are generic, so we need to specify these parameters. Type of the key, type of the value. So let's just for experiment purposes, let's make a hashmap with a key which is a name, and a value which is, I don't know, just an integer. This can be your age or something. So we're going to construct our hash map with keys that are strings and values that are integers.
For PA2, we could say it's a hash map of strings and linked list.
Linked list, angle bracket, integer. Because linked lists are also generic. Yep, you got it.
Okay, cool. That's pretty cool, actually.
It is, right? All right, so let's put some stuff into our hash so we can say put key comma value, and we'll start storing things into our hash map. So let's do map.put. I don't know. Put down how many years I've been at. Alright, so we're just putting some random data into our hash map. We're using a method in this class called put. Put takes a key and a value, and it associates that value with that key. So let's read Phil's data. So I'll use the get method. Get will take a key and return a value. So I'll say map.get Phil, and whatever value it gives back, I'll print that out next to Phil's data. And then I'll do Gene's data equals, and I'll do map.get Gene, and that should give back, you know, something weird because Gene's not in here. So let's just try this so far. I forgot something.
You put a comma instead of the period.
Thank you. Now I went from 2 errors to 3 errors.
Yeah, that's kind of how that works, basically. It gives you more errors after you fix one.
Right? Okay, so java.utility.hashmap is not correct. Hashmap. Alright, there we go. Let's run this sucker. So Java hmain. So Phil's data was 1, Gene's data was null. Right? So it told me that I associated a 1 with Phil. When I asked what was associated with Gene, it came back null, which tells me that Gene is not in my hash table. And if you click through on the, actually I think it'll tell you up here, get object returns the value to which that key is mapped, or null if the map contains no mapping for this key. So I can use put to save information. I can use get to see what's associated with something. We don't need to delete, but if we needed to, I could call remove to get rid of an object, key value pair. And then let's just go ahead and use our toString method.
So in Java, does it just automatically assign a key, just assign whenever it chooses the index of the hash table to have the key and the data?
Yeah, it's figuring out where to put it in the underlying array if it's using an array. It may not be. It's probably doing either probing or chaining to handle collisions, and depending on what it's doing, it's got private methods to, reprobe or to create a linked list or whatever. All of that is hidden from us, right? All we know about a hash map is this stuff. We know how to construct it. We know the methods for accessing it. But what happens when we say put? No idea. Right? Sometimes maybe it takes the key, hashes it, uses that as an index, copies the value into that location of an array. Sometimes it might rehash a few times because there was a collision, or it might take the key, run it through a hash function, get an index, go there, find a linked list, add this to the end of the linked list, or maybe it'll add it to the beginning of the linked list. Or maybe it's not a linked list at all, maybe that's another hash. Or maybe when I said put this, it found the load factor exceeded 0.75 and it created a larger hash table and rehashed everything and stored it into the new table. No idea. All we're saying is map.put. And all we care about is that, hey, after I say map.put fill comma 1, if I say map.get fill, I want to see 1. And that's it. That's what the hash map is to us. So again, abstract data types, right? This stuff up here, this is how we see a hash map. This is how we interact with the hash map. But all those other details, those are on the other side of that firewall. Those are the implementation. And those are hidden from us. Those are, in some sense, unimportant to us. Performance-wise, we might care about it, but in terms of using the hash map, we don't care what's happening under the hood. All we know is that after we say put, if I say get, I'm going to get back whatever this value was that I put. And if I put something else in here, if I were to do another put statement where I put, a 2 with fill, then this would return a 2. Alright, so I added one more statement here. Let's print out the hash map, and I'm just going to concatenate it to a string that says map equals, and see what the toString method returns. And it's going to be glorious. It's this nice, comma-separated list of keys equals values, all inside curly brackets. And so I can see, the 4 pieces of data that I put into my list. And the order is, pseudo-random. I put Nick in first, and Nick ended up in the middle. I put Zog in last, and Zog ended up in the beginning. But, we don't care about that. There's nothing about a hash map that says in what order you should get those values back if you do something like convert it to a string. And so let's just make sure this is really a key. So let's change Phil's value and add a bunch of 1s. And now when I run it, when I print out the value of the hash map at the last line here, when I concatenate it to a string, you can see Phil's value has changed to 11111. So let's try something. So let's remove Nick and let's print out the value of the map. And then let's put Nick back in there. And let's look at the map one more time.
What's the difference between put and add?
Add will give me an error. Put will not. Thank you.
Okay. I think you're still thinking about using a queue or...
Yeah, I'm still thinking linked lists probably. Or just not thinking. So yeah, there's what the list looks like after we changed Phil to 111. Then we removed Nick, and this looks exactly the same as this previous list, except Nick is missing. And then when I added Nick, well, Nick went back into that same spot in the middle here. And so the position of Nick in this string looks like it has nothing to do necessarily with the order in which you put these things in, but it probably does. So you could do some experiments and reverse engineer what the hash function is by looking for collisions, maybe, or you know, trying to make things hash the same index and so on and so forth. But none of that is our concern, right? If there was something that we were concerned about as far as some detail of the hash map, there would probably be a method to give us the information that we're looking for or allow us to make the modification that we want to make. And the idea is, if there's not a method or a field, you know, that lets us interact with some aspect of the hash table, then that aspect is hidden from us and should not affect us, right? So it's this very, very clear demarcation between here's the stuff the user does to interact with the data structure, and here's the stuff that, you know, makes that happen. And the only way you get from that top level to that bottom level is through, you know, in this case, these methods. All right, so that's all you need for PA2 as far as hash tables go, I believe, right? You have to be able to add things. You have to be able to check to see if a value is in the table, and you need to be able to call the toString method, which you can do by just concatenating it to a string or calling map.toString. Let's see, so our code for adding to an existing linked list is the same as creating an index in the hash map because Java creates it dynamically. To add to an existing linked list, we would say get. So we'd say, you know, index.get and the word, and that would return a linked list. And that linked list has an add method, so we could say all of this dot add parentheses and the integer that you want to add to the end of the linked list. And this has nothing to do with, you know, whatever linked lists the hash table might be using internally to handle collisions and so on and so forth. This is the linked list of word locations that we're building as we parse the input file. So I don't know if that responded to your comment or not.
I'm not saying that the code is identical for a linked list. I'm just saying in the PDF it separates or makes a distinction between adding something to an existing linked list and creating a linked list.
Mm-hmm.
It seems like you adding and creating a linked list is dynamic in Java, so you can use the add function and it should just work fine.
Not exactly. So and I might be misunderstanding, but the main thing is, let's say this is not in here, right? And let's say you read your file and you see the word dog and it's at location 22 in the file, and you want to add that to your hash table, right? In this case, I need to create a new entry in my hash table associated with dog. I need to store an empty linked list and then have that linked list contain a single thing, which is 22. So I had to construct a linked list put a 22 into that linked list, and then add that linked list to my hash table associated with dog. But now later on in my file, let's say I get to position 30 and I see the word dog again, I'm not going to construct a new linked list. In this case, I'm going to get this linked list and I'm going to add a 30 to the end of it. So for a new word, you're going to construct a linked list, add it to the hash table. For an old word, you're simply going to get the already existing linked list and use that list's add method to add a new reference. Some new words, you're going to change the hash table. Old words, you're going to change a linked list in the hash table.
Doesn't Java do that for us, or do we have to do it ourselves?
Do what?
Check whether or not the key exists before seeing what we do with the linked list.
Right, the difference is if I create a new linked list and I say add that to the... Let's say I've got this situation where I've got dog associated with 22, and let's say I see dog at location 30. Here's what I don't want to do. If I create a new linked list containing a 30, and I say store this linked list associated with dog, it's going to get rid of this linked list, and it's going to make this linked list, and my 20 is gone.
Okay.
Right? So if the word is in there, you got to find that linked list first, and then add to the end of that. So yeah, so if you see only one entry for each word, and it's the latest entry in the file, that's probably what's going on.
Usually I thought that's what Java does for us. But when I mean by that, I mean like if we were to, like if you search a key and the key doesn't exist, we just kind of, we do like what's it called? It's like a put function.
So
or put method. And with the put method, just add the name and then add the linked list.
yeah, if I say just go ahead and add dog with a list of 30, it'll go ahead, and if dog's not in there, it'll create a new entry and put it in there. That'll happen for us automatically. The problem is if dog is already in there and I say go ahead and add dog with this linked list, it'll erase the old entry for dog and replace it with this new linked list.
Oh, so you have to kind of clear if statement saying that
Yeah.
if it already exists, just do the linked list and that's it.
Yep. So that's where I say that's the one method that probably has 2 lines of code in it, because you have to do that if first and do something different.
Alright, cool.
All right, I think people are in good shape. So that's PA2. That's enough to get it done. I've given you until Monday morning for this. I believe it's doable by Friday, but since we didn't start talking about it until today, I'm giving you until Monday morning, so there's that later due date noted. Future assignments will go back to Friday morning due dates. So the grading on this might be a little wonky time-wise, but Canvas should list it until 8 a.m. Monday morning. So go ahead and get started on that. Come by office hours if you got questions. Otherwise, I will see you on Wednesday. Have a good one until then.